I'm here to talk to you about OpenTelemetry, which is an exciting new standard for observability. So first I'm going to be like, okay, what is observability? Define it real quick. And what is it and why is it so hard, which is why we need OpenTelemetry. And then I get to tell you a lot about OpenTelemetry, what it is, what it isn't, what you need to use it, when you should use it. And spoiler, it's hard too. But it's really useful. The motivation here is that this is your team. This is your team. There's some people on your team, and there's some software on your team. Because my objective as a developer is to provide useful capabilities to millions or hundreds or billions of people. And I do that by operating software that provides those capabilities to people. So for me to succeed, the software's got to be running. It's got to be up and responsive. And so I count the softwares on my team too. Now with the people on my team, I can find out how they're doing by asking them. I mean, they might answer inaccurately, but together we can probably figure out what's going on. With the software, it's harder, or at least different, because we're separated from the software by this barrier between the human and digital space, which Dr. Woods and Cook from resilience engineering, they call this the line of representation. And it's the line of representation because in order for us to know what's going on in the digital space, the software has to tell us. We get screens, we get command lines, we get buttons that we can click with our mouse, and that's it. You kind of get what you get, except that we're software developers, and these are computers, and so we get what we provide ourselves. So observability is all about getting that software to tell us what the heck is going on with it. To answer questions like, okay, what's going wrong? Or why is it slow? And then wider questions that particularly as like a developer who mostly changes code, I need it to tell me how it works at all. I mean, not just why does it not work now, how does this ever work? Because we support more software than we can keep in our heads. You know, we don't get to, sometimes you get to like write something new and then understand it thoroughly because you were there as it grew from something tractable into the complex system that it is. But more often we join a team and here's some software that we don't understand, or we're on a team and somebody's like, oh, look at this piece of software, it's yours now. Or even maybe I've been on the team for a couple years and I just haven't touched this recently. And I need to find out where to make the change, and I need to figure out how to know I made the change correctly. And we can do that if we get the software to tell us what's going on, like live and dynamically generated, because the documentation is out of date, period. Still useful, also out of date. Okay, so with good observability, we can answer these questions, and it serves the functions of onboarding, but also just I can support more software because when I need a refresher, I can get one. And then the one that sells to management is that you can reduce downtime because it makes you drastically faster at figuring out what's wrong. Can you get from there's a problem to I need to look at this code right here in like 10 minutes? Sometimes that works. And then you need to improve performance. You've got to know which part is slow. And also like concurrency makes this complicated. Where would you even go to improve performance? So all of these things we can get our software to tell us. And that's observability. We can see what's happening because it's letting us know. Stuff is running below the line that puts a representation on the line that we can look at. And this word comes from like rocketry. And observability comes from rocketry. And the data that powers observability, that mediates between the software and our representation, is called telemetry. So this is data that's just for our purposes as operators and changers of the software. It's not user data. You know where the rocket is and how fast it's going because it tells you. We get that data from code. We put code into the software to make it tell us stuff. And that code is called instrumentation. So this can look like a log statement. Something as simple as that. It's there for our purposes. Logs are your kind of classic observability, right? They've been around forever. They're easy because every log line is independent and it's got the common format of a string. So we can do a lot with logs. They're really, really cheap to store, and they're way better than nothing. I'll give them that. But they're really good for when you're doing one thing at a time, like locally when you're running something and the only person doing anything in that service is you, so it's exactly one thing, so the order of the log lines actually tells you something. Then they can be useful, but they don't scale, right? They don't scale to when you're doing a whole lot of things at once. And there's a lot of this service running, and now all those independent log lines are totally mixed up and really hard to get anything from. We've gotten better with structured logs and aggregators, and now we have tools like Splunk is one, or Humio, log scale, whatever, that work really hard to tie the log lines back together. But it would be really nice if they tied themselves together, because when the software emitted them, there was some correlation that we've lost by dumping everything into a string. So, right, logs are a bunch of these things happened, indeed. Great for auditing. Different purpose than observability, totally different. So logs and metrics are observability, and they're what we've had in the past, and they're still pretty useful. Metrics are great for the weather. You know, if I was evaluating a self-driving car, I would want it to tell me in great detail what it did and why, but I would just want metrics about how wet was the road and what was the temperature outside. That affects what we're doing, but it's not like decisions we're making. In general, metrics have some cool properties, like that you know how much they're going to cost. A single metric is typically a single time series, and it doesn't matter how many hundreds of different instances of a service, for instance, contribute to that metric. The metric has a fixed cost to store. But then you have you have the metrics you have, and you had to decide what you wanted to have. And when you want to zoom in, it's just pixels. You get what you stored, and that's it. So you can't decide during the incident, hey, no, I need to know which instance is getting all the errors. No, you aggregated that. So they're not enough for really figuring out what our software is doing as developers. We need to know, by instance, by customer ID. And you do not want to store this many metrics because they are a fixed cost per metric. And if you have 1,000 customers, you don't want to take that cost times 1,000. You're not going to do it. And then you get the walls of meaningless dashboards. Okay, so observability, modern observability, the state of the art says, how good can we make this? If we control the software, what can we make it do to really express what's going on without spending all of our time on this because we actually want to write some code? Okay, so modern observability pipelines, you've got some instrumentation in the code, emits the telemetry, and that results in observability somehow. So with logs and metrics, you've got this thing happened, this many of it, but what I want is this thing happened, how long it took for performance, and why it happened. What was the previous thing that caused this? What inbound call resulted in which call to which services, all the way down. So they're interconnected. And, and then we're still blocked by the line of representation, so there's a little more to that. We need the representation itself. So the telemetry is going to feed into a database somewhere, and then there's going to be some UI that's going to access that database and show it to us and let us learn stuff. And that is called a telemetry backend. This is a stupid name. I don't like this name. They call it a backend, I guess, because they're looking at it from this perspective, and this is the database that they store it in, but it's also the front end. It's the whole point. Whatever, this is the terminology. It's fine. Right, so if you're looking at logs, your backend will be like your log aggregator backend, right? Which is also the UI that you look at your logs in. And if you're looking at metrics, then you'll have a time series database involved, and so that's like Prometheus, and then Grafana is your UI, typically. In general, for optimal observability, we want distributed traces. So I'm going to talk a bunch about distributed traces today because these are the state-of-the-art. They can be enough by themselves. They're not in every tool. But you want the graphs, you want interactive queries, and you want the story. You want the software to tell you a story of how its day is going and how it ever works. So that's state-of-the-art observability, rich events that are interconnected. Oh, and then I'm going to show you a thing. So to bring this to life, let's go over to, here's an app that I'm running in Kubernetes. And this is the OpenTelemetry demo app. So it has like 10 services in 8 different languages. It's gratuitously complicated just to be like realistic microservices and have a lot of examples. But here you can, on this website, which you can go to, by the way, jessitron.com/otel. You can click around. And if you click around, we'll be able to look at your traces. So you can put stuff in your cart. And then I'm at my cart, and then we can do a checkout, place order. It's all a very fake e-commerce site. And then I can come over here to Jaeger. Now, Jaeger is a telemetry backend for just traces only. And it's the open source. Zipkin is also another one. But Jaeger's the big open source tracing. That is not on the screen. I was doing things. Okay, well, they weren't very interesting. Yeah, okay, exit PowerPoint maybe. Now I want you to mirror displays. Is it mirroring? Okay, now can you see the website? Okay, great. So you definitely had the URL then. All right. Yes, here's the little e-commerce site. I'm going to click on something. I'm going to put it in my cart. I'm going to hit checkout. Place order. There we go. Now we're going to come over to the Jaeger UI. Okay, so right, Jaeger, standard, open source. I'm trying to be vendor neutral here. Trace program. It is not the best. Do not think that this is the best the most you can get out of distributed traces, but it is like adequate, especially if you just want to run something locally and play around. And plenty of companies do run internal instances of Jaeger. I don't know anyone who's happy with it, but it's better than nothing. Anyway, so I can look, here's all the different services that are sending telemetry, and I can pick one and then just hit find traces, and or not, or not. Oh, there we go, okay. Oh, so I mean, this is the demo app. And the Jaeger app just runs until it runs out of memory, and then it restarts because it's Kubernetes. Let's click on it some more. Yeah, because like running a telemetry backend persistently and safely and like reliably is non-trivial. I'm not attempting to do that in this demo. I'm just running it. Okay, there we go. Okay, so up here I can see each of these dots represents a trace. The bigger ones have more spans in them. And then I can scroll down and look for something interesting here. Here's something mildly interesting. Okay, right, so each of these traces represents a request from the front end to the back end. It happens to be started at the front end. So that big wide span at the top took as long as it took. It took 143 milliseconds. You can see that most of that was network. because in the middle there is the back end, the front end proxy. So here's the list of services that it went through. And then these little, the names of the spans are this smaller font, get product, get product, get product. Somewhere at the top, there's an http.get. So what URL is it getting? You can click on these guys and get more details, and I can go into the tags, and I can see, here's HTTP URL. So it's hitting recommendations. So this is hitting the recommendations API, which makes sense because it's going to recommendation service, also feature flag service, and a bunch of product catalog. Okay. Oh, and check this out. You can see that, shrink this up again. There we go. Front-end proxy took this long. First, it went to recommendation service, and it did these things. Let me shrink this up. Okay, and after it went to recommendation service, then it went to product catalog service. So if you wanted to speed this up, you can either speed up recommendation service. Well, you could probably improve your network responsiveness, but that's different. You could speed up recommendation service, or you could speed up product service. But we are calling product catalog service multiple times here. No, those are inside each other. This one, though, this one happened at the same time as these. So here's a really fast one, and here's a slower one. I don't know why. But you can see what happened in parallel and what happened sequentially. And in the stupidest little node apps, I have turned on tracing and been like, oh crap, that's a concurrency bug. It makes them really easy to see. So I love it for that. Every line in here represents at least 2 log statements, start and end, because it always has a start and an end. Plus, all of those different fields in there are often also added as log statements. So let's get some, you get a bunch of automatic stuff, all this HTTP, blah, blah, blah. And each of these app dot probably would have been either a field on every log statement or log statements of their own. So typically a single span, these are called spans because they're like spans of time, represents 2 to 10 log statements. But they're better than log statements because they have friends. They're like part of a story. It's like you don't just get a sentence here and there and over there and over there. You get the whole tale. So this is what we're after for state-of-the-art observability, especially in the back end. Great. Okay, we did orders complete. We can go back to PowerPoint. We can do this. Good. Right. And here's the, in case my demo doesn't work, I can still show you one on a slide. All right, so distributed traces are made of correlated events. They all have a name and a duration, and they're called spans, and a span represents a unit of work. You always want a span to say, I'm about to call this other service, and you always want a span for, I got this request in, and you often want a span for, I'm going to the database, or I'm making this calculation, anything that's like really interesting. Each one references its parent. So in logs, you often have like request ID that you pass down and down and down and down so that you can put them back together again in Splunk later. These ones have what trace am I part of and which span is my parent, what caused me. So it makes like this causal chain of things. So they add up to a trace. And here's the trick. Every service is in on it. So checkout service and product recommendation service and product catalog service and feature flag service, they're all participating in the trace. Okay, so here's the summary. If you have a list of things that happened, they also have relationships with their parents. You can see there's like this tree structure. That you all know where each one came from and how long it took and where that fits on the graph. And if there's errors, you can find them immediately and find you can drill down until you get the lowest one that's like the deepest one in the tree to find the error that's actually caused the error that the front end returned. That's your super fast, get me to the code I need to look at. And then they all have the same, oh yeah, they have a bunch of fields attached to them which are useful, and they all have the same trace ID. Okay, so this helps us answer how does it work, what is slow, and what's failing, although it is sometimes really hard to know. You have to look at a trace to find this, and how do you know which trace to look at? Open question, at least, but I can show you some of the ways in Jaeger when I open that up again later. But this is harder. This is harder than logs. Those independent strings are easy to spit out. Because like this service that's going to tell you what happened, it has to pass that trace ID along on the request to the other service. So this goes in your HTTP headers, or your gRPC metadata, or your Kafka message metadata, or whatever. You have to add that trace ID. And it has to be in a compatible format, so each service, in whatever the heck language they are, have to know how to read that out of the metadata and start their own spans in the trace. They have to participate. So that's, yeah, there it is. It has to emit the same thing. So that's a lot harder. And this is where OpenTelemetry comes in, because you need this to be compatible across languages and across web frameworks and all kinds of things. So there used to be 2 standards for this. There was open census and open tracing, and at some conference one day they were talking to each other and they were like, man, there should only be one, so of course they created a third. But actually they both deprecated. Open tracing and open census were both deprecated, so they really did merge. And OpenTelemetry is bigger than either of them ever were, and it's really, this isn't somebody's open source project. This is a very serious foundation-governed open source project. It includes protocols, the protocol that we transmit the spans in, also the way we transmit the trace ID between services, although in some cases that's an even higher level standard. Semantic conventions, like what are we going to name these things? And then the instrumentation. And here's the crucial bit of you want observability, but you don't want to spend all your time on it. So there's instrumentation. One, there's a standard API, so any code you write is portable between vendors. You're not bringing in the Datadog library and coding in Datadog language, whatever that is. So it's portable between vendors, and it's standard, and other people can open. It's even like they try to make it uniform between languages. And then there's implementations of both the high-level API and the automatic instrumentation. And the automatic instrumentation is super useful because it'll do stuff like, well, I know what a web request is, and I know you received one, and I know you want a span for that. And it makes one. So that means bringing in, or instrumenting your application is often as simple as importing a library, maybe a few lines of code to configure it, maybe a few environment variables, but often you get the instrumentation for free, given that you can import a library. Right, also in OpenTelemetry, there's the collector, which I'll talk about in a little bit. There's the demo, which you've already seen. Documentation, websites, Slacks, Zooms. It's the OpenTelemetry project is part of the CNCF, the Cloud Native Compute Foundation. It is the second biggest project in the CNCF. The top one is Kubernetes. So that's like the level of governance we have. We've got special interest groups and working groups. There's an ambassador program. There's like OTEPs, which are the like change suggestion thingies. Maintainers and approvers and reviewers, and not just one set of maintainers and approvers and reviewers. No. There are ones for the specification. There's ones for the semantic conventions. There's ones for Java, ones for .NET, ones for PHP and Ruby, and. There are hundreds and hundreds of people, probably thousands by now, involved in this. Like officially, I'm sure there's thousands of contributors. And this is necessary because we need really wide compatibility. We need all of the services to participate. So we need all the languages and we need all the standard frameworks to be able to participate in this. So it had to be open source. At Honeycomb, we've been all in on OTel for years. We've been like, just use OTel, just use OTel. We don't want you to be locked in. Because before OTel was a thing, we had to write our own libraries that were proprietary in the sense that all they did was send data to Honeycomb, and you had to use their API. And we had like, I don't know, half a dozen of them or something. Beelines, we called them. And we had to maintain them. And if we wanted people to have an easy time sending data to Honeycomb, we had to write something in their language. And oh my gosh, no. Let the whole community supply the whole community with what they need. So OpenTelemetry is fantastic for this. Right, and so now you've got open source instrumentation, whether it's libraries or you write it yourself. Either way, it's emitting standard telemetry that can go into any OpenTelemetry backend. And there are many of these. Datadog supports this. Splunk supports this New Relic. Honeycomb has been in there early. Lightstep is another one. There's a bunch. And of course, the open source tools like Jaeger. Okay, so what this gives us is a standard API. Like you can always, across languages, you can get something called a tracer provider that knows how to send the spans. From that, you can get a tracer. You give it your library name if you're making instrumentation for a library. From that, you can start a span. Whenever you get a span, you can set attributes on it. And then you can end it, which that's when it's actually transmitted, is when you end it, because then it knows the final duration. You can do this yourself. And then there's the magic concept of context, which holds like, where are we in this thread of execution? So that's going to put the parent span and the trace ID on any span that you start. And this is all open source and standardized. Now, it's very different between languages in some case. In .NET, this is gonna, you just use system.activity. .NET practically implemented these abstractions already, so the OpenTelemetry instrumentation feeds into that. In Java, if you're using Spring, of course, there's all kinds of magic. Java's like the easiest one to use OpenTelemetry with. In Go, it's a pain in the butt because you actually have to pass around a context because Go is very anti-magic. Node works really well in the browser, not as well in the various browsers. So it does vary a lot by language, and every group has adapted these standards, which are set out in a specification of these are the concepts in OpenTelemetry. So the concepts transfer, even though the implementations are, they fit in the language dialect. Idiomatic, that's the word. Okay. And then there's automatic instrumentation. So if this is your app, and these are your libraries that you use, like here's a database client, and there could be a Redis client or something like that, there's automatic instrumentation for those. You bring in that library, and it sends stuff to the tracer provider, which ships your, yeah, and then you can do your own set attributes. So you can set attributes on spans that were created by the automatic instrumentation. And that's the beauty of it. You add like 2 lines of code to set your custom attributes for like your customer ID and what matters to you as a business, and they just fit. And then all the spans, they go and they come together, and it's beautiful. Yeah. Also, these automatic instrumentations, they'll plug into like your HTTP clients and servers, and it'll do that propagation of the trace ID and the span ID for you. And that's actually a W3C standard, the trace context header. So that's even standarder than OpenTelemetry. Right, so auto-instrumentation helps like that. Auto-instrumentation provides the structure, the basic outline. This is, in Node, for instance, this is everything. I mean, if you're using Express and any of the standard HTTP libraries, this just creates all the spans that you need for incoming and outgoing HTTP requests. That's the whole thing. Bring this in and import it. That's like it. Now that's going to send to a local collector by default, which I'll talk about in a minute. The traces for the demo are pretty much auto instrumentation. You get what you need if you're using like Spring, Express. Typical frameworks is pretty easy. Pretty easy. Never perfectly easy. Something's going to go wrong somewhere. But then what you get from that is a bunch of generic fields. So you get the URL or the route or the host or something. You get the user agent. You do not get all the headers, and you never get the body of the request because that could contain sensitive data. So when you want stuff out of your headers or out of the body of the request, you need to put that in yourself in custom attributes. And custom attributes are really what makes this pop. So that's where you get the app.order amount and the order ID and the tracking ID and the currency and the user. This is the stuff that lets you look at a trace and say, okay, who is experiencing this failure? Why is this one different from the ones that are faster? And here you can put whatever your app makes a decision on, I throw it in as a custom field so that then I can see it in the trace. And that anything I would log, I set as an attribute instead. But this is like even fewer lines of code. This is Go, but this one grabs a span out of the context, which you have to pass around, but that's a standard Go thing. And then set some attributes on it. There, you can set whatever you want. And then this one also logs it, but generally I would replace my logs with the spans or with the attributes on the span, which is not adding an additional span. Okay. So custom, a lot of automatic and a little custom instrumentation is optimal. Which brings you to the question, question I get a lot is how do I know whether my language and framework are supported? So I'll give you my secrets. One is to go to the registry, OpenTelemetry.io, and then there it is. Right. And this is where you search. So the trick is to go to the registry and then scroll down until you see the search bar. And then you can be like, I don't know, is Redis supported in my language? And then you scroll down some more. And you see the different languages. You can also filter by language and stuff like this. So this is where I go to find what automatic instrumentation is available that my app might use. And then at the language level, there's documentation for a lot of them. Here, C++, .NET, Java. The .NET one is actually really good and really well supported, but it's not 1.0. I'll mention why later, but it should be. That's a fight. The Java one has the most contributors and is the most mature. Node is also great. But yeah, there's a lot of them here. The other place that I go is their GitHub repo. So if you go to github.com/open-telemetry, somebody's sitting on OpenTelemetry without the dash, rude. So open-telemetry. And then you can go to your repositories and you can search for your language. And you'll see, here's the main one. OpenTelemetry Java is going to have the OpenTelemetry SDK that you would use for custom instrumentation. And the and it also has a bunch of like the really solid components, some automatic instrumentation, some exporters and stuff like that. The contrib has packages that are less, that they're like, okay, people are contributing this, but we don't think they're as solid. But I use stuff out of contrib all the time. And then Java instrumentation, they've broken that one out in Java. So you can go here and then you can click and then you can look at the contributions and look at what's changed and the standard things that you do for how well maintained is this particular open source project. But that's the trick, is to go to their GitHub repo and search for your language. Do it, PowerPoint. Do the thing. Uh-oh. Did it show the GitHub repo and stuff? Yeah. Okay, good. Because it switched back to extended displays. Sneaky. Okay. Yeah, and there's those, but we saw those already. Okay. Now we're starting to get into the hard stuff. I talked a lot about putting the libraries into your app, but then you have to send those spans somewhere, and you need to send them all to the same place, or it won't construct into a nice little trace. So we need everybody to send to the same backend. Now, normally, okay, so like locally or when I'm playing around, I totally send stuff straight to Honeycomb because free Honeycomb account is like the easiest thing. But in real life, in production, you're always going to send them to someplace central and have that place have the configuration for where your backend is. So the collector, the OpenTelemetry collector, is a process designed to do this. It receives telemetry, traces, metrics, or logs, and then it sends them on where you want. And it can do some processing in between. It does a lot of conversions. So it'll take Prometheus metrics and convert them into OTLP metrics or some other kind of metrics if you want. StatSteb and Prometheus are both supported, and it has some log formats. It has open census and open tracing. So if you actually use those older standards, you can leave them in the apps that are using them, and then the collector will just convert them into OTLP, which stands for OpenTelemetry, the Ellis Silent Protocol. Right, so receivers, exporters, and in the middle you can do all kinds of processing. This is an example of collector configuration, so it likes YAML. Bummer. I hate YAML because you can't cut and paste it because indentation doesn't come through. All right, but you can set up where do you want to receive traces. The standard is OTLP. OTLP works on HTTP or gRPC. It really likes gRPC. It likes protobuf in either case. It will very reluctantly accept JSON over HTTP, but it is like, what are you doing? This is way too much data. Use something more efficient. So it really likes gRPC or HTTP with protobuf. And then exporters is gonna, ooh, look at that. Oh, wow, it makes an arrow. Okay, exporters is gonna, you can send it, this is just going to the collector's log itself, which is useful in Kubernetes when you're playing around. And then I've got it sending to Honeycomb. Configure where to send it, here's the header. And then there's processors in the middle, which you pretty much always want to use the batch processor, and maybe you want to use the memory limiter to like, that's a back pressure thing. But also, where's my slide with, yep, so many processors. Also, there's a lot of different processors, and you can do things like, oh my God, this looks like a social security number, mask it. You can do things like, okay, these two services couldn't agree on a field name, let them send what they want, but I'm gonna transform environment ID to environment underscore ID in all cases. And then you can like do some massaging of your data, you can filter it, you can be like, these spans are just noise, I don't want them, that kind of thing. Oh, and it can run as an agent, so you can also drop a collector. It's quite common really to drop a collector in as a sidecar next on whatever machine or pod your services are running in, and have it collect and then forward onto a central collector. Also, that collector, the OpenTelemetry collector, can sit there and gather metrics. So it'll do the metrics gathering that like a Datadog agent or something will do. And this way, collectors are running in your network, in your production VPC. Everything running in your VPC should be open source and standardized and not belong to a vendor. And that way you have more control and flexibility. It'll take logs and metrics too. You can have pipelines for those. OTLP logs, I don't know what the point is really, but they want to be thorough. Compared to other log formats, it just has a special place where you can be like, okay, this log was emitted during this span, and so then you can like get to the span and back and forth. Similarly with metrics, why, I don't know, but it's nice to have a good standard format and a good specification. And there's a place for including what they call exemplars, because like when your error rate spikes, the question is always, how do I get to a trace that represents that problem. What is happening? Tell me a story, give me a trace. And an exemplar is, it has to do something special during the metric collections to find a trace that might represent that, but it does give you a way to click. At Honeycomb, we don't do metrics separately. We just aggregate over the traces to give you your metrics. So it's completely trivial to click back and forth. That's a different paradigm. But right, so OTLP metrics, it's a thing. It's not as important as the tracing. There are some weaknesses. So client side is rough. Browser support for magical knowing what span you're part of. We get a little bit out of Zone.js, but the demo app is a React app on Next.js that is using all the auto instrumentation that we have. But you can't tell, like, you can get like a notification on click. This is a whole separate talk. And you can get the requests going to the back end, but I can't tell you which click caused which request to the back end because React. So that's tricky. Asynchronous messaging, you can totally express, like if you're doing event sourcing, you can totally express, okay, here's the event that came in, which we did this processing on, and then that resulted in these processes over here. There's a debate, do you want those in the same trace or in a linked trace? Or because you can link like the span to, well, it would be the other way around. Here's the span that put a message on the queue, for instance. And then when one reads it off asynchronously, maybe as a batch process, you want to start a new trace over here because it could be much later, but you can link back to the original. So there's stuff you can do with asynchronous messaging. And there's also a working group that's trying to like give you advice on that, but it's still a weakness. And it's not done yet. So here's the status. I mean, the big thing is it is the industry standard. Enterprises are using it all over. And it is the direction of movement. And the specification for the protocol is super solid. And the major languages are super solid, even though .NET isn't 1.0 and growing. But the sticking point is the semantic conventions. What are we? Is it http.url? Or is it target? Or is it route? Or is it root? Bike sheds, biggest bike shed. The stuff that matters the least is what people will argue over about the longest. And we can't get that working group to come to an agreement and call this set of field names 1.0, and that's why .NET isn't 1.0. So really, it's very safe to use. It's just that some field names could possibly change. The world will not end. Yeah. So there's constant progress, but it's already the standard and it's already good. Alternatives to OpenTelemetry. OpenTelemetry does expect that you can, in some way, modify the code that you're instrumenting. If you can't or are terrified to, there are alternatives that like sit around, like as agents or in the network. eBPF is, people are very excited about this. This is like, let me stick some point cuts into the kernel and do some stuff, but it doesn't have your business logic and it doesn't really know, okay, you sent this request out, which incoming request was that related to? Maybe you can do some sneaky things, but not usually. And it's not gonna have your customer ID and it's not gonna have your order amount and the things that are important to your business. So in systems that you can't change, useful alternatives. If you can change them, you're gonna get a lot more value out of using OpenTelemetry. Okay, so what you have to do is go home and either run a local Jaeger or sign up for a free Honeycomb account, which is way easier. And then you can bring in the OTel libraries and you can totally send data to Honeycomb or to a local Jaeger from your development environment. This is a very normal thing to do. And you can see what you can get. Even you can try it with one service. If you can get two of them hooked up, even better. Also, you can use it for tests. People use telemetry around their tests to track failures and stuff, and it's great in CI. It's also super low value in CI. You will never need more than a free Honeycomb account. For your continuous integration, track your builds. What takes so long? Where can I improve performance? But then in real life, it's harder. You need libraries in all the apps. You need to run at least one collector, maybe several. And then you have to either run or buy a backend that actually persists this stuff and is reliable. Okay, about choosing a backend. Oh, how do you find the right trace? This is everybody has a trace view. I mean, they vary on how useful they are, but everybody has one. If I go back over to Jaeger, do y'all see Jaeger? Okay, cool. This is how you find traces in Jaeger. You can click on a dot, or you can scroll down. You can also, you can do this. Sometimes this works and sometimes this doesn't, and I haven't figured out the criteria here, but you can say things like app.sessionID equals blah-de-blah, and then you can get, this is actually all of the traces triggered in my session of clicking for some time period that is before this. So you can get like just those traces that meet that criteria. I don't know how fast this is on a lot of data, but it's there. And I mean, you can look for an error code, for instance, and that's what you get. And then you can click into something and get a story. Very nice story. Back. And then some people keep separate metrics. If you're using Jaeger, you're going to need something completely separate for metrics. Some tools, Honeycomb, like just aggregate over your traces, so you can we do without metrics. And then can you just send your local data? Can you see your builds in it? And more, yeah. And then are you going to run it yourself, or are you going to buy it as a service? So if you run it yourself, this is definitely hard because you have to worry about databases and stuff. You typically don't want your telemetry backend. So maybe Cassandra and Jaeger or whatever, you don't want this running in the same VPC as production, ideally, because if production is having problems, you need to diagnose those problems. And if your observability is having problems because production is having problems, you have even more problems. So you want this decoupled. And yeah, I mean, it takes some serious maintenance and a team to keep it up to date. And there's a book for that. The observability engineering book was written by 3 people at Honeycomb because we did build a database for this. And then Charity and Liz and George tell you how and a lot of the considerations that you'll need. Okay. Or you can buy it. And then do some research on how well it really supports OpenTelemetry. Because at Honeycomb, we're like, screw these beelines, we're deprecating them. OpenTelemetry all the way. Because we really do want to compete on product. But Datadog is very reluctantly, I mean, this is just my impression. I haven't run it myself because terms of service. But some places support it to varying degrees. And then find out what the pricing model is, because is it volume? Are your custom fields going to cost you more? Custom metrics are very dangerous because they explode costs. Custom fields on spans are much less, but still, also consider network transfer. There's a lot of people who would like to use Honeycomb, or who do, that a significant portion of the cost is actually transfer from their VPC to ours. So consider that. And then ask, how will you sample? Because all the spans are too many. And sampling is when you filter them and you send some spans but not others. Specifically, you want to send some traces and not others. Because like your logs, you save everything, right? Because if you lose any of it, it's just going to be like kind of random which ones you lose, and you'll never be able to get the whole story of a request. But with traces, you have like an ID that says, okay, this is one story and this is another story. And if these are stories about health checks, you do not want to keep them all. You might keep one in 100 or maybe even 1,000 if it's just a health check. If this is a story of an order checkout, Maybe you want to keep all of them, or maybe all of the failed ones, or maybe all of the ones that took too long, or maybe you want a spread, but you want to keep something from every customer or every region. It gets really complicated. You don't want to save all the spans because storage for these is a lot more expensive than logs. Logs are just strings. We're pretty good at storing those. S3 can take them all. But these, you need to access them in a way that stitches them together and puts them into a trace and searches and aggregates and blah, 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 more expensive. So you don't keep them all, and you can sample intelligently. You can do it the easy way, which is completely randomly decide at the beginning, am I saving this one or not? But then you don't get to save all the errored ones. Or a careful distribution over customer IDs. Well, unless your customer ID is passed in, then you can. Anyway, you can also do tail sampling, in which you have like another piece of your pipeline. After your collector, you go to, at Honeycomb, we have an open source project called Refinery that is a distributed tail sampler that's like, okay, I'm gonna accumulate all the traces, and as soon as the root span ends, I'm gonna figure it's done, and I'm gonna make a decision. And I'm either gonna sample it, which means keep it, which is confusing, or I'm not, and then I'll drop it. So that's you wind up needing an observability team even when you're not running your own backend, because some of this is hard. Challenges, yes. So we talked about not every framework is instrumented. Somebody needs to establish standards internally. Somebody has to be in charge of this. Maybe it's an observability team, maybe it's an architect, who cares? Maybe you're small enough that it's just a developer on the team who has a passion for this. If you have internal libraries, great place to add some automatic instrumentation, even if it's just setting attributes. Internal libraries are a great place to like magically implement observability or make it better. But somebody's got to do that. Somebody's got to operate the pipeline, at least some collectors. And there's always problems. I mean, there's the internet, fortunately, because it's open source. But somebody's got to get their head around this. What is a span? What does it mean when my trace IDs are all zeros? It either means it was sampled or that you haven't, that the SDK hasn't initialized yet, and you need to wait a little bit. So somebody needs to know that stuff. Which, I mean, you can choose to be the expert. A trick to being the expert is you don't have to know anything yet. You just have to declare yourself, I'm going to be the one who fixes OpenTelemetry problems here, and then people will bring them to you, and then you'll figure out the problem, and gradually you become the expert. You don't start that way. You just invite the problems, let them come to you, and you will become the expert. The volume can surprise you, and that's where sampling comes in, but sampling is something that you have to tune over time to get the right amount of data. And finally, your traces don't get really good until you start using them for debugging, especially when developers use them, because developers get in there and they're like, okay, I need to add a feature. I need to pass discount code through to the pricing service from the front end. All right, where do I need to change some code? And you get into the pricing service and it doesn't have enough instrumentation, you can't tell. So you add some. And then you add discount code as a field so that you can see it flowing downward and know where you dropped it. And as you do this, you wind up being like, if only I knew the customer ID here, or why it declared the discount code invalid. If only I knew the expiration date that it retrieved. And then you add that. And it just gets better and better as you use it. We call this the instrumentation loop of using your instrumentation, improving it, using it again. This is our power as developers. This is what we can do because we work in the computer and we work on the computer, and we can make it easy for ourselves. So your job as a developer, I'm almost out of time. Your job as a developer is not to be sufficiently smart. It's to make your job easier by making the software make it easy for you. And then when you make it easier for future you make it easier for everyone else too. And that's how we get to be part of a team. Favorite quote from State of DevOps 2021, which is last time they focused on observability and monitoring. Teams with good observability spend more time coding. So yes, it's an extra thing to think about, just like testing, but it can replace logging. And in the end, it's gonna keep us from spending a lot of time debugging production. And it's gonna help not just us, but our whole team. Charity, our CTO, says, individual engineers can write software. Yes, you personally can write the code, but you are not gonna keep it up through all the holidays and all the sick days. This takes a team. It takes a team to ship and maintain and operate software and to keep it going after you've switched jobs and everything. And observability can help us now because you can do it locally instead of logging, and then the debugging that you needed locally scales to production. It's still useful, and you can go find it, and you can go look at whether the change you made had an impact on the world when you query over some traces and say, look, the performance got better, or the performance got worse because it's doing this extra thing every time that I added. And this many people are using it. That's really satisfying. So it's good for you, and it's good for your team, and it's good for the team that you don't actually have because you've left and other people have arrived. Yeah, so keep your software on your team. Make it a good teammate. It's up to you to train it to teach you what's going on. The end.